Hello?
Good. All right, I'll get started. Welcome to my talk on media on Android. My name's Edison. I'm principal engineer at Spiral, working on a video app that will be launching soon. Previously, I was working at Twitter Vine for Android team, responsible for all the media components. When I first submitted this talk about half a year ago, I was being very generous with myself and didn't realize how broad this topic is. So when I made my slides, I realized I have to cut it down. So I consulted some friends and see what they're interested about. It turns out people are watching videos on their mobile phones, and doing it on Android isn't so easy. As LTE has been covering more and more countries over the last couple of years, there's more and more video streaming apps. And doing it on Android isn't easy, so I'm going to cover most of it with video playback. At the end, I may touch a little bit of recording if there is time. So what is a video? For the purpose of this talk, we're going to define it as a stream of bytes that represents a series of images and sound to be presented on the screen and speaker in a predetermined pattern. So we're going to cover image, how we show images, how we get the sound, and how we show them in the pattern it was meant to be. And for video playback, we're basically we're talking about the process of taking some bytes either from disk or from a network location if you're doing streaming, and eventually show it onto a surface or dump it to an AudioTrack on your phone. For most of the use cases, who is not familiar with MediaPlayer here? All right, everyone is familiar with MediaPlayer. You'll know it because it's really easy to use. For the most of the part, you just set it up, prepare it, set your listeners, and dispose it when you're done. But unfortunately, the only thing it supports is you can start, pause, resume, and you get some keyframe seeking on it, nothing else. And it also has limited support for container formats. So if you want to do a HLS stream or a dash stream that you can easily do on iOS, it's not possible to do it well with MediaPlayer. And it gets stuck really easily. There's this crazy diagram that I refuse to show here about all the states that all the costs and the orders you have to do to make the video player work. And many times, due to bad implementations on the manufacturer side, if you call things out of order, your app will get stuck and the user will have to reboot their phone. I see a lot of people nodding there. I guess a lot of people have encountered this because it's really easy to get it wrong. There are ways to alleviate this problem. If you just put it on a separate thread, handle a thread, and you queue all your messages, and you just send everything through a message, and you drop things when needed. And most of the case, it also requires a surface to prepare the player, and that makes it really tough because the view will be the owner for the players, and not your activities. Because of this, it's really easy to have your media player hanging around for longer than it needs to, or if you want multiple of them, it's very easy to go out of the budget that's allocated for your app. In that case, the user may have to reboot their phone again. So it's really risky to use MediaPlayer if you're using like a scrolling view, like a list view or a cycler view. So make sure if you have multiple of them, keep track. I talked about surface just in case people don't know what a surface is. It's a handoff onto a raw buffer that's been managed by the screen compositor. So think about it as a hardware layer that is managed for you by the screen compositor, and all you do is putting a stream of images on it. You can make a new surface if you have a surface texture. So if you're using a surface view, there's already a surface generated for you. If you're using a texture view, you have the surface texture and you just give it to a surface. If you have none of them and you're doing a GL view by yourself, you can generate a OpenGL texture object and just give it a name, and you can have the surface from that. And to do all this, it's kind of complicated. The best resource here is the Graphica collection. It's a collection of hacks that some Googlers did, and they just dump it into this repository. It shows you how to do screen orientation changes and keep the media player. It shows you how to do screen recording. How do you record like a video from just inside the phone? It's really great. You guys should really check it out. And a lot of people asked the difference between what a surface view versus a texture view. Most of the cases, you want to use the texture view. This used to be different since texture view is only supported on ICS or above. But for now, since we're in the ICS stage, you should almost always use a texture view because it respects all the view properties. So let's say you have an action bar and you wanna scroll through it. Surface view may not keep the Z orders, but texture view will. But sometimes, knowing surface and media play is not enough, and that's why all of you are here. We can't do adaptive playback. We can't do custom buffer control. We can't do playback rate change, which a couple years ago I heard from someone working at Coursera that was the biggest feature request for them, because people want to look through videos, look through lectures, and do it at a very fast rate. Unfortunately, Google has put all this together in an open source library called MediaPlayer. It's probably the best thing that happened to the media world in the last couple of years. It was open source in 2014. It got a lot of attention. It's been actively developed. They solved a lot of feature requests along the way. And it's pretty reliable since API 16. It supports Dash, HOS, and all the streaming formats out of box. And you can easily extend it to support the encryption method you want and have frame level seek if you want. It's highly customizable. But in order to customize it, we kind of want to know what's under the hood. So for the rest of the talk, I'm going to go through all the components that make up the ExoPlayer. If you think about the journey of how the structured bytes eventually get on the surface, it kind of looks like this. If you look at all the blue islands as like little queues, and you're basically taking queues from one pod to the next pod, and just piping it through, so eventually you get to the presentation stage. And it's like a stream of bytes that's continuously happening, and each of these islands you need a separate thread to do the pulling and to do the pulling between the input and output. The first stage is to get the structured bytes, which is your file container format, decoded into encoded frames. Or in the sense of audio, you'll also be encoded frames. You have the media metadata retriever that was initially built for the gallery app, where you can show a list of videos that user take with the duration, the title of the video, and the thumbnails that the user wants in the gallery app. It's really easy to use. You just create it, and you can open a video file, and you get all the data from all the metadata from it. If you want the actual frames from the video, you kind of want to use something like the media extractor. The media extractor is supported since API 16. It decodes most of the formats you want, like MP4 files, etc. really well. Or you can use a third-party library like FFmpeg. FFmpeg for the sample decoder, it's actually fairly quick because the media extractor also runs on the CPU. If you want to decode HOS or a Dash stream, you want your own manifest manager because you're downloading this manifest and you have to understand it. ExoPlayer comes with the parsers as part of the library, but if you have new formats that you want to support, you can certainly just easily import the Java version as well. In order to get to the media extractor, you just create it and give it a path, and you will open the file or the network destination. you'll have access to all the streams. You pick the streams that you want, and you read the sample read the sample data into a buffer to be processed later, and then when you're done, you can just release it. And the next stage is to get the encoded frames that we just got from the media extractor into the raw image or audio. For this, you can use FFmpeg, but for most of the part, it's too slow because you'll be running on the CPU. But you'll have to deal with the licensing issues and padding issues. So your best bet is probably using either the native code and interact with the OMX, or you can use MediaCodec, which is supported also on API 16 or above. MediaCodec is pretty good for decoding since API 16, but if you want to do any encoding, like encoding the camera frames when it comes in, you want to use it since API 19. The reason is when Google wrote the MediaCodec library, they didn't specify some constraints. For example, like the color format, the output is supposed to be. So if you're using API 16, depending on which Samsung phone you use, they'll be in a different color format. And you will be scratching your head because you'll just see random blue striped image gets outputted. But since API 19, Google added to the CTS test suite, which is the test suite that every phone that's compatible with Google Play Store have to pass. But before that, you can always use the Surface as a proxy because Surface uses this special color format designed for Android, and it works with all the Android components. To create the MediaCodec, you just configure it using the specs that you know prehand, and you loop through the inputs. You have a thread that loops through the input buffers. As soon as you get an input buffer, you fill it and you make it. And you put it in, and another thread, you'll keep taking the output buffer. And whenever those threads are ready, you can read the result. When you're done, dispose the resources, because you also have a limited number of connections to the media server. One good thing about MediaCodec is that the battery usage if you're using MediaCodec are not counted towards your app. And after we get the raw bytes, we are finally at the audio presentation stage. The audio is basically a pipe between decoded samples and the audio output. You put small chunks of samples into it one at a time. You never want to leave it thirsty during playback, because if you leave it thirsty, you will have silence in the middle, and it will be appeared as gaps, lags. You can do your fading, you can do all your effects over here when you have the raw data. So for example, if you want to do a seamless looping like Vine, one thing you can do is you can post-process the data you get from the raw samples and just do a time-weighted fade between the end and the beginning of each track. And also, because the audio presentation is a continuous stream, the amount of samples you put in divided by your sample rate will be the measurement of time, and that's the time truth on your playback. The only thing you have to keep in mind is there's this famous audio delay on Android framework. Depending on the device and SDK you're using, you get different results, but it's minimal enough that unless you're doing frame by frame seeking, you should be okay. For the video presentation, you'll use whatever you put into the audio already as the timestamp, and you'll be basically showing you'll release a sample to the user, and then you're going to make it shown until the next timestamp for the next frame is reached. If you're doing any playback rate change, and this is where you will do it, you'll get all the frames that you want. You'll scale the timestamps based on the playback rate. You'll also do the fading and the pitch change to your audio. And when you're done, you show the frame at a quicker rate. Play around, you need to play around with the timing tolerance depending on how fast the device is sometimes. because let's say your decoder is slower than the number of frames you need to show. You will need to do your frame skipping appropriately. When you're doing the video presentation, this is also the time where if you want to do any screen recording, you can copy the data from the surface that you get from the decoder into another byte buffer, which you can use for other purposes. We have time, so I'm going to go over recording next. For recording, it's basically the reverse process, where you have sensors, which for video, you will be camera, and for audio, you will be the mic, and you're eventually going to construct the final files. The role for encoding is very similar. The only thing you have to do is for the camera colors, you could use Renderscript to convert the camera color to the color that you want to be encoded. It's super optimized NDK code that treats heterogeneous color conversions really fast. It's 50 times faster than do it in Java. Because it's done using in the GPU in parallel. When you get the camera frames, you can also do image manipulation during that time. If you want to do any cropping, rotation, inversion, if you're doing like a mirror view, or if you have two cameras running at the same time and you want to have both of them recorded at the same time and merge the frames, that's where you can do it. And for that part, it's really easy if you just use Canvas and do some matrix stuff in the standard SDK frame. And then you encode it to the video frame. That's probably where it's going to take the longest. If you do it through MediaCodec, it's fairly fast, and you can probably do it in real time. And this is also why in the last couple of years, apps like Periscope, Meerkat are able to do live streaming really well. The only thing you have to watch out when you're doing recording is you want to avoid garbage collection at all times, because intermediate objects are initialized and reused will help you not generate a lot of garbage, and garbage collection will pause the entire world for you. And when the world is paused, if you run out of samples that gets inputted from the mic and you're not consuming them, you're gonna have dropped samples, and user's voice is gonna sound really laggy and choppy. The way to solve it is, if you can, pre-allocate some buffers ahead of time. That will facilitate in some sense. And but the camera API, the camera 2 API, is what you really want to use. It's asynchronous. It handles all the buffer generations for you, and also it's very low level, so that you have full control. When something goes wrong, you know exactly what timestamps you went wrong. Two tricks that you can also do here to help you generate some buffers. One is you can set the large heap equals to true. Don't do it for most of the apps. The other developers will yell at you because your app will be forced out of the process background a lot more frequent than normal. And you can also use a separated process, so for more RAM budgets. So for example, the maximum RAM you can use for most of the apps per process is half a gig. But on your main process, where you're showing the user the interesting stuff, you kind of want to do all your network there, because that's going to generate a lot of garbage, and you're going to have GC. You don't want it to interfere with your recording thread. So when you put your recording thread on a separate process, you will not be interfered by anyone else that's generating a lot of garbage objects. I mean, my hope is that with art, this issue is minimized by a lot. So how do we get the audio from the mic? There's this class called AudioRecord. It basically continuously gather all the samples from the mic in small chunks, and all you have to do is record when you get the samples and put them on the queue yourself. The samples from the audio are fairly small because they're audio and it's just a waveform. You can do any pre-processing when you're doing the recording. Let's say you want to have this funny voice, or you're doing like this really deep voice. You can do all your processing over there. but you have to run the audio record in a separate thread. And the thread, you have to just make sure you specify the thread priority to be urging audio, because that signals the system that no matter what happens, your thread will have the highest priority. And again, make sure you avoid any garbage collection during this process. Video from the camera, you want to use this method called preview frame that gives you the camera data in MV21 format, or you can set a callback using the set preview callback. But however, with this, you use a new byte array for every frame. It's going to be really laggy, and it wasn't designed to do this. So if you're using Camera 1 API, you want to use the preview callback with buffer method, and this way you can manage all the buffers. You can manage all the buffers yourself, and knowing how many buffers you need, and keep the frame rates change if you're like running out of buffer. Or you can just use Camera 2 again. If you want to support Camera 2, it's going to be a lot easier because you have all the low-level control. Any questions? Yes. The question is, do we want to buffer the video like 10 seconds ahead of time? Yeah, you can absolutely do that. So with ExoPlayer, you can have a data sync. They have the concept of data sync. So what you can do is, you can start downloading videos ahead of time. So let's say there are two cases. For MP4 file, you can always just start downloading the file, and you can manage it through your HTTP layer. So you're doing the caching yourself that way. Or for streaming, you kind of just want to use what they have in terms of adaptive. Okay, so for dash content, you wanna do the caching. Yeah, you can do that. You can do that. So in order to do that, you need to change the way they're doing the parsing. When they parse parse the manifest, because the manifest tells you exactly where the locations are. Sorry?
How do you tell the player to stop buffering?
Yeah, so that's basically the two queues over there. So the question is, how do you tell the player to just keep buffering? You kind of have to hack in the ExoPlayer to tell it just not release the content, but keep downloading the content. You don't want to decode the content ahead of time, because those are going to be huge images that you can't keep in memory. Does that answer your question? Kinda. Sorry?
After recording the audio, you want to stream it out. How do you encode it?
So the question is, after you record the audio, how do you stream it? Yeah, you're going to encode it with MediaCodec. MediaCodec, yeah. You basically just set it up to encode in the audio mode, and you tell you exactly what format you want it to be out with. So in this case, it'll probably be AAC or MP3. Yeah. Sorry?
The mic encoding, can it do G7, 11, VLAR?
That does not come with Android. Yeah. Yeah, for any of the unsupported audio or video formats, you generally do not want to do that because it will be too slow to process in real time. Yeah.
You're recording audio on one thread and your video on the other. How do you sync the two based on that timestamp?
That is a great question. So the question is, if you're recording audio on one thread and doing video on one thread, how do you sync up the frames? So for audio, you're gonna get chunks of samples from audio record. The time minus the length of the sample will be the starting point of when your audio sample happen. And when you get the frames from the camera, depending on if you're using camera 1 or camera 2, so for camera 1, you generate a timestamp. You generate the timestamp when you receive the camera frames. And for camera 2, they'll tell you exactly when the frame was recorded.
So maybe it's just a tip, but I'm able to use 300 megs of memory and shared memory to store my video frames.
Okay.
There's an Android OS memory file.
Oh.
And it allows you to store video. You can use it like a separate file.
Yeah.
Use the memory map file and store video frames.
I see. So, pro tip here that's given to me that there is a shared Android memory file deposit that you can put in. Android.os.memory farm that you can have this shared memory of 300 megabytes. Yeah, I will look into that. Thank you.
What's the cooling containers? What's the strategy for this, to display videos? Like, let's say I want to display bunch of videos in recycle view. Do I go with texture view? Is it gonna respect all those translations which recycle view?
So the question is, if I'm using recycler view, can I have multiple videos at one time? Yes, you can. If you're using recycler view, you want to always use texture view. Texture view will behave like a view because it's basically a normal view with the hardware layer that's managed for you on the position of the screen.
Can I have OpenGL rendered right?
Yes, you can have OpenGL. Yeah, yeah. It's basically manage the GL view for you. Yeah. Sorry.
Sample to use exoplayer with texture view instead of surface view.
Yes. Yes.
In the repository, they have only surface view demonstration, not texture view demonstration.
I think they only. Sorry. Can you repeat the question again?
In the repository, they have only surface view implementation as an example.
Yeah.
But not texture view.
No, they only have the, yes. So the question is, in Exoplayer, are there any server examples, right? Oh, texture view examples, no, there is not. Yeah, sorry. Yeah, so if you wanna use a texture view with Exoplayer, you wanna look into the graphical library. The graphical library shows you all the cool things with views and media together. Yeah.
Is there anything that I can do to measure the drop frame rate? And is there anything that I can do to signal to the server that to reduce the video quality?
The question is if there's anything we can do to detect drop frames. Yes, so when you output your next frame, essentially you have a loop running that tells you when to release the buffer. So let's say the next time the loop comes back, and like the next frame was supposed to show 20 milliseconds ago, that means you have a drop frame. Yeah. Any other questions? All right, thank you everyone. If you have, I'll still be here. And thanks everyone to come to the talk.